Okay, you can look at this question. The question says two masses m and m by 2 are connected at the two ends of massless rigid rod of length L. The rod is suspended by a thin wire of torsional constant K at the center of mass of the rod. The figure is deceiving. Center of mass will be somewhere closer to this. So the string is attached somewhere here. Restoring torque is K into theta for angular displacement theta. If the rod is rotated by theta naught and released, the tension in it when it passes through the mean position. So that is tension in the rod. See, neglect gravity to get the answer. So they are rotating it this way and they are going to leave it. When you leave it, it is going to go back to its mean position with some kinetic energy. Basically, there is some potential energy stored in that twisting wire, which will be converting as kinetic energy. So you can go with the analogy like if spring force is K into X, energy will be half Kx square, or you can integrate torque d theta integration will give you half K theta square. So potential energy stored in that twisting thing is half K theta square. Now when you twist it and leave it, when it comes to mean position, there will be some omega of the rod which will be given by potential energy if it is converting as kinetic energy. Kinetic energy is half I omega square, I about center of mass. This distance will be L by 3, 2L by 3, that you can calculate. Moment of inertia about this axis I need to find, which will be m into L by 3 square plus m by 2 into 2L by 3 square, which will turn out to be the ml square by 3. So potential energy is going to convert as kinetic energy. Now why we are writing this is we need tension. Actually this is the first equation we have to write. We can write F equals to ma for either this guy or this guy. I am writing for this guy. Net force towards the center equals to m omega square r. So tension equals to m omega square into radius is L by 3. You can write for this guy also, it looks the same. So if I want to find tension, I should find omega. If I have to find omega, I will be going with energy conservation. I have to find omega and substitute, or I can take the ratio because I don't need omega. So when I take the ratio, I will be getting the answer straightforward. So we need to find tension. So tension equals to, tension is the guy who is providing centripetal, but tension is a function of omega. We have to find omega using energy conservation.